welcome to our channel. This is Science Lectures 256. Please consider subscribing, like our videos, comment on the videos, and follow us on our social media platforms, that is Twitter and WhatsApp. So we are still continuing with ecology, and currently we are going to look at the ecosystem, an ecosystem in ecology, what it is all about, and the nature of the ecosystem. So by definition, we need to first define what an ecosystem is. So an ecosystem, by definition, is a basic, we define it as a basic functional ecological unit, basic function ecological unit, which includes the biotic components interacting with the abiotic components, interacting with the abiotic components. In other words, each of the components influences the other. So that is an ecosystem. But before we go further, from the definition, we've said basic functional ecological unit, which includes the biotic components interacting with the abiotic components. And initially we said biotic are the living components of the ecosystem. Then we said abiotic are the non-living components of the ecosystem. So non-living, they interact and each influences the other. And we said for us to have an ecosystem, it should come right away from a community. If we have a community interacting with the biotic components, it gives an ecosystem. So that is basically an ecosystem introduction. But where did this term come from? The word ecology, the term ecology, the word ecology was coined, the word ecosystem, because we are looking at the ecosystem. Ecology is the one at large. So we are looking at the term ecosystem. So the term ecosystem was coined by a scientist known as Arthur Tansley. This guy coined the term ecosystem, but this guy, he did this in around 1973. That is when he coined the term ecosystem. So Arthur Tansley coining the term ecosystem, and that is the definition of the ecosystem. But before this man coins the term ecosystem, there is another man we need to talk about, very important, and this guy is called Carl Moebius. And Carl Moebius had also introduced a term called biokoinos. And biokoinos means organisms, living organisms interacting, or communities interacting. So we have a community of these organisms interacting. But basically we are having living organisms interacting. But these organisms, you say they are interacting with what we refer to as a biotope. So in summary, what we need to know, to give a summary of this, if we have biokoinos plus the biotope, they yield what we refer to as an ecosystem. So biotope plus biokoinos, we get what we call an ecosystem that was coined by Arthur Tansley, that scientist. However, Carl Moebius also defined this, what biokoinos means. So basically this is something like an introduction to what we are going to see within the ecosystem. So ecosystems can be artificial, or they can be natural. Artificial systems, they can be natural systems, they can vary in size, they can vary in age, and many other aspects. So artificial or natural ecosystem, they can vary in size, they can vary in age. So we should take note of this when we are looking at ecosystems. However, all ecosystems are referred to as open systems. So they are all open systems. Open systems. Why are they called open systems? Because they have the capacity to allow in input or inflow of materials as well as outflow of material. So this input is input of energy. Energy, we see that ecosystems allow in an input of energy. They also allow in an input of organisms. Organisms can enter into a new ecosystem, an input of nutrients, and they can also allow an outflow. Energy can be in form of sunlight energy that is input into the system, organisms that enter into that ecosystem, nutrients that are entering into that ecosystem. Then we can have an outflow in form of immigrations. Immigration can happen, and there is an outflow from that ecosystem. So they are open systems, they are not closed systems. They can allow in inflow and outflow. So outflow can be through immigration, getting out. Then inflow can also be through immigration or entering, immigration or entering into the system. So this is really basic and very important for us to know that ecosystems are always open systems. So them being open systems, we want to also see, now we've seen this input, but what are the factors that affect the degree of input? Which factors can affect the level of input into a system? Factors affecting what can affect the input into the system. So first of all, number one thing that can affect input into the system is the size of the ecosystem. The size of the ecosystem. So how does the size of the ecosystem affect the degree of input or the level of input into this ecosystem? We realize that whenever we have a small ecosystem, it relies more on externals or on external input. However, if the ecosystem is large or big, or large, if it's large, it is more self-sustaining as compared to a small ecosystem. So the degree of input into this system by the externals is determined by the size of the ecosystem. Then the age of the ecosystem. So the age is also very important. You realize that ecosystems that have lasted longer are less reliant on externals as compared to new ecosystems that have just emerged, because for them they are not that self-sustaining and self-perpetuating. Then another thing we can consider here is the metabolic activities or demands of that ecosystem. The higher the metabolic demand, the more it will depend on the externals. Then finally, another factor that can affect input within an ecosystem is the ratio. We can refer to it as the ratio of the autotrophs to the heterotrophs. Remember autotrophs, auto means autotrophs from light. Then these autotrophic organisms are capable of synthesizing food using sunlight energy. So you realize that if an ecosystem has autotrophs that are a high load of autotrophs, the ecosystem can synthesize and manufacture food, as compared to an ecosystem which has more of the heterotrophs. So the ratio of these should be kept in synchrony, in balance. They should be in balance or synchrony, such that we have an ecosystem that is well sustained. So increase in autotrophs is far more better than a higher increase in the heterotrophs. So if we have limited autotrophs, this ecosystem will depend more on the externals. So these are the factors that affect input within an ecosystem. So we want to look at the nature and components of the ecosystem, but we'll start off with the components of the ecosystem. So when we look at our ecosystem, it will have, all ecosystems will have components. So we are going to have a look at the basic components of each ecosystem. So an ecosystem, we expect it to have the organic components, and organic components, for example, we shall give examples of organic components. For example, carbohydrates. Carbohydrates are organic components. Then we can give examples of lipids and proteins. At least an ecosystem should have the organic components, carbohydrates, lipids, and proteins. We know that living things, most living things, are made up and built by the proteins. So an ecosystem should at least have the proteins. Carbohydrates are necessary for energy, and lipids are building blocks, in fact stemming from the cell membrane of these organisms. We have a carbohydrate at the cellular level, we have a lipid at the cellular level, we also have proteins at the cellular level as organic components. And this reminds you of the introduction of ecology, where we say that the definition of ecology by Ernest Haeckel was that is the study of the organic domestic life, the domestic life of organic life, domestic side of organic life. That's how we define it. So components, we can have organic, like we've said, carbohydrates, lipids, proteins. Then another component of the ecosystem, they can be inorganic components. Inorganic components, for example, sulfur, phosphorus,